Welcome to The Explainer. Today, we're diving into what is honestly one of the most frustrating bottlenecks in tech right now. Think about it. Have you ever had this incredibly deep, engaging, long conversation with an AI, only to come back the very next day and realize it has completely forgotten who you are? Yeah, it's literally like talking to a brick wall that just resets itself every 24 hours. Kind of like a digital version of the movie 50 First Dates, right? Well, today we're going to break down a really groundbreaking new architecture called Nemori, which promises to finally give AI agents a genuine, evolving memory.
So you gotta wonder, why does this happen? Why does a fantastic chat with an AI always end up with it greeting you like a total stranger the next time you log in? If we want to build truly autonomous agents, ones that can actually act as our long-term assistants, they absolutely have to know our history, our preferences, and the whole context of our past interactions. But right now, they just don't. And I'm sure you've been there, finding yourself having to re-explain your entire coding project or your dietary restrictions every single morning just to get back to square one. The researchers in our source material actually refer to this as LLM amnesia. And honestly, this is the core bottleneck standing in the way of that grand vision of a truly personalized, self-evolving AI. The problem really comes down to technical limits, specifically the limited context window of large language models. There's also this really interesting phenomenon called lost in the middle. It's basically when an AI acts like it's hastily skimming a massive block of text, and it just completely blanks on the crucial details buried right in the center. Without a persistent, long-term memory, the whole illusion of a smart assistant shatters the second you start a new session.
Okay, so let's dive into this and look at how the industry has tried to fix this issue so far. The current Band-Aid solution is something called Standard Retrieval, or RAG, Retrieval Augmented Generation. Now, RAG is awesome at pulling facts from static documents to keep an AI from making things up. But when you try to use RAG to help an AI remember its own past conversations, it fundamentally breaks down. Because RAG treats a dynamic, flowing human conversation like a static library book. It relies on offline indexing and these clunky, stateless information patches. And that simply does not work for the complex reasoning an AI needs to actually remember a real dialogue.
This really brings it home and illustrates exactly why that old way fails. Standard RAG relies on arbitrary, fixed-size chunking. Let's say you ask, "What color is the apple?" The AI says, "It's red," and you reply, "Yes, I love it." Well, standard chunking might draw a hard, arbitrary line right after that, completely splitting the conversation in half just because it hit a word limit. So later, when the AI says, "It's very healthy," that piece is completely separated from the context of the apple. It makes no sense. But contrast that with Nemori. Nemori uses episodic segmentation. It actually understands the meaning of the conversation and groups that entire interaction about the apple into one beautifully intact, logical episode. And that brings us to the real paradigm shift. The researchers introduce Nemori, which stands for Self-Organizing Agent Memory Inspired by Cognitive Science. Now, the key here is that you shouldn't think of Nemori as just a hard drive where data gets dumped. It's not that at all. It is a human-inspired, dynamic, self-organizing framework. It actively takes the agent's lived experiences and transforms them into an optimized, continuously evolving memory. It's a total game changer. To actually pull this off, Nemori relies on a dual-pillar cognitive framework. It separates memory into two distinct types, which perfectly mirrors how our own human brains work. First, you have episodic memory. These are the lived narrative experiences, the detailed play-by-play story of an interaction. Then you have semantic memory. This is the abstracted, distilled, factual knowledge you pull away from those experiences. By separating those raw, episodic details from the abstracted facts, Nemori avoids clogging up its system with redundant info while still keeping all the rich context of the conversation. But, before you can even store a memory, you have to define what a memory actually is. In the field, this is known as the input chunk challenge. Older systems use these primitive, heuristic-based approaches, basically just rigid rules of thumb. They'd chunk memory by single messages, or bundle one prompt in one response, or just arbitrarily cut the text when it got too long. And as we saw, all that just leads to a fragmented mess. Nemori solves this by grouping memories by actual self-organized semantic events. So how does it do that? Well, Nemori uses its first major innovation, the two-step alignment principle. It's inspired by event segmentation theory from cognitive science, and it basically provides a top-down method for organizing a messy, raw conversation into a coherent narrative. Think about how you naturally recall your own day. You don't remember it word for word, right? You remember it in distinct chapters, like driving to work or eating lunch. Nemori does exactly the same thing. Let's break down how this actually works on the fly. It happens in two steps. First, Nomori has this intelligent boundary detector. While you're chatting, the AI is constantly evaluating the context, the timing, and any shifts in what you're trying to do. The moment it detects that the conversational topic has fundamentally shifted, what they call a semantic boundary, it triggers step 2. It takes that chunk of conversation and hands it over to an episode generator. This generator elegantly packages up that chat into a cohesive, third-person narrative and even gives it a title that captures the core theme.
Okay, so grouping memories logically is fantastic. It preserves the context beautifully, but it raises a pretty massive question. How does the AI actually learn and evolve from those memories? Because ultimately, we want proactive machine learning here, not just a really well-organized filing cabinet.
This is where the system gets really brilliant. Once a new episodic memory is created, Nomori does something fascinating. It takes just the title of that episode and uses it to kick off a proactive learning cycle, which then generates true semantic memory. They call this Nomori's second major innovation, the predict-calibrate principle, and it is directly inspired by how human brains operate, specifically the free energy principle. Think about how we learn best. If you try to solve a math problem first and then look at the answer key to see where you messed up, you learn way more than if you just passively read the solution, right? Nomori does exactly that. Step 1. The AI uses its existing knowledge to predict what happened in a new episode, based just on the title. Step 2. It calibrates. It compares its prediction against the actual raw ground truth of what was said to find the gap, the novel info it missed. Step 3. It distills that error into brand new semantic knowledge and integrates it into its system. The big takeaway here is that proactive knowledge evolution vastly outperforms passive information storage. Older memory systems just relied on predefined rules to passively extract facts. But by actively distilling its own prediction errors, Nomori lets the agent actually learn from its mistakes. It bridges the gap between what it already knows and what you just told it, achieving genuine adaptive evolution over time. And get this, the results of this architecture are absolutely staggering. In rigorous benchmark testing, Nomori didn't just beat older state-of-the-art systems in accuracy and reasoning, it did so while using 88% fewer tokens compared to just feeding the AI the full conversational context, an 88% reduction. By turning complex reasoning tasks into simple, pre-reasoned memory retrieval, Nomori is just fundamentally smarter. And for us, that means faster responses, way cheaper computing costs, and a remarkably more capable AI assistant. So at the end of the day, Nomori is proving that AI memory isn't just about storage. It's a framework for continuity, context, and continuous learning over time. It transforms our agents from these forgetful, frustrating tools into truly cohesive companions, which leaves us with a pretty fascinating thought to end on. If your AI finally has the framework to perfectly remember its past with you and proactively learn from its own mistakes, what on earth is it going to be able to predict for your future? Think about that. Thanks for joining, and I'll catch you in the next explainer.